Hey there, Mr. Maestas here, and I got a really quick video for you, okay? Solving rational inequalities. So I've already gone over solving polynomial inequalities, and we're going to use the same technique, which is use a sign chart or a number line to graph, but to solve rational inequalities, okay? So the steps are you need to find the critical values and then use a sign chart or a number line to determine the intervals in which it works. So let's take this example. This is the example that I kind of went over in class. We just talked about it, but we were wondering, how do we solve this inequality? This is a rational inequality. Well, the first thing we also want to do is make sure that it's less than or greater than, or that the inequality is equal or greater than or equal or whatever to 0. We have 0 on one side, okay? So here's what we're going to do. The critical values for a rational expression, okay, a rational inequality, are going to be all values that make the numerator equal to 0 or give you a vertical asymptote, or basically making the denominator equal to 0. Okay? We know that the denominator can't be 0, we're gone, right? We can't have the denominator equal to 0, but that's a point of discontinuity, and we have to include that in our number line. Okay? So, our critical values. This numerator cannot be 0, so we don't have a critical value there. But the denominator can be 0. So our critical value is x equals 3, and we get that from the denominator. Now we know that x can't be 3, right? Because that will give you 0. Well, but that's not the point. The point is that that is our critical value. So when we do our number line here, our critical value is 3. Now, even if this was a less than or equal to, we cannot include 3 in our answer, right? So because 3 is not, we can't have this to be 0, this is not included. So let's find the values that are less than 0. So we're going to do the same thing we did with polynomials. We're going to check values that are on this side or that side of our critical values. So let's choose 0. When I plug 0 in for this, I'm going to get 1 over negative 3, which gives me negative. And a negative number is, in fact, less than 0, right? So this is going to be negative. If I have, let's try 5, okay? 1 over 5 minus 3 is going to be 1/2. 1/2 is a positive number, so there's my positive. So I have a negative and a positive number. I want values that are less than 0. That's my negative value. So that's all these values here in interval notation. Negative infinity to 3. Alright, so that's how we solve this rational inequality. Let's look at another one. So I've got another one here. X plus 4 over x minus 3 is less than or equal to 0. Okay, give me a second, and you know what, I'm going to go over to the camera. I'm going to turn over here and zoom in so you can see this closer. Alright, so we're back here with this one is a little zoomed in here so we can see what's going on. Now we have to take both values, one that's going to make our numerator equal to 0 and our denominator equal to 0. So x plus 4 equal to 0 and our denominator equal to 0. And likely, you know, some teachers like to say it's not equal to 0. Okay, negative 4 and 3. Those are our critical values, right? Critical values. So we got negative 4, 3. Now, this is a less than or equal to, so this is going to be a closed circle. Even though this is less than or equal to, this value does not exist in our domain. So we're going to have an open circle there. All right, let's check a value like 0. So we're going to plug 0 in here, and I'm going to get a negative 4/3, so this is negative. Let's plug a negative, let's go negative 100. We'll just get really big, okay? Negative 100 is going to be negative on top, negative on bottom. A negative divided by a negative is a positive. So this is positive. Stay positive. I like to stay positive. All right. Let's pick a big number over here, 100. The point I'm taking, the reason I'm giving you big numbers, it really doesn't matter. I'm only looking at the sign, right? So I put 100 over here, it's going to be positive. Positive. A positive divided by a positive is a positive. Stay positive. So we want values, although the answer is going to be negatives, right? Less than or equal to 0, which is negatives. That's everything in here. Okay? So our interval for the solution of this inequality is going to be -4 to 3. Bracket here because it's included. Parentheses here because it's not included. And bye.